Hello everybody, it's Mr. Roy. I hope you're having an awesome day so far. In this lesson I'm going to be taking you through the first part of our unit on sequences and series. This is also sometimes called discrete functions, but we're going to be referring to them as sequences and series. So the first one we're looking at today is called arithmetic sequences. Let's dive in. We got to talk about terminology first, and so the first thing I want to talk about is this term called sequence. This is an important one that we know what it means. So sequence is just a set of numbers that are in order. So you'll see in purple there I've written a set of numbers that are in order, and you might be able to tell what the pattern is going on there. And so that is a sequence. Any set of numbers that's in order we can call a sequence. Now within sequences we've got a whole bunch of numbers. We call each of those a term. So a term is just any of those numbers in the sequence. So our example there is 5 is the second term in this sequence. So we see we've got first term, second term, third term, fourth term. You'll often see 3 dots, just like you can see right down here. And those 3 dots are going to mean if they're at the end and there's nothing after it, it just means that this sequence goes on forever. If there's 3 dots and then another number, that just indicates that there's a gap in between, and the terms that are in between those 2 numbers are not listed. You might also hear things called, instead of term, called an element or a member. And those just mean the same thing, but for our purposes, we're just going to call them terms. Okay, so we're going to use a new notation that we're going to learn. This is how we're going to refer to terms. So our first term in our sequence, we're going to call term 1, and we'll just call it t with a little subscript 1. Okay? And of course that just follows that T2 is our second term, T1063 is our 1063rd term, and then there's this one called the general term, and that's Tn. Essentially you can think of that as a formula for generating terms in our sequence. So if we want to know the 100 or 1063rd term, if we know our general term, we can just plug in some simple stuff to figure out what our 1063rd term is. So our general term is kind of like the formula for our sequence. Okay, let's try this out. So we've got 2 general terms here. These are 2 completely different general terms, each for a completely different sequence, different set of numbers. And if we start plugging things in for this, we're going to get our sequence. We're going to get our set of numbers. And so we're going to start by plugging in a 1 to get our first term, wherever we see an n. And then we'll plug in a 2 to get our second term, wherever we see an n, and so on and so forth. So I'm going to do that right now. And let's figure out our first 5 terms in each sequence. Okay, so for our first one, if we want to know our first term, we're just going to type t with a subscript 1, and that means anywhere in our general term we see an n, we're going to put a 1. So this would just be 2 to the 1, and so 2 to the 1 is just 2. For our second term, we'll write it like that, and that's going to be 2 to the 2, which of course is 4. Our third term, we'll put as 2 to the 3. 2 times 2 times 2, or 2 cubed, that's going to be 8. Our fourth term, that's going to be 2 to the 4. 2 to the power 4. And so that's going to be 16. And our fifth term, T5, is going to be 2 to the power 5, and that'll be 32. So the first 5 terms that we've got are 2, 4, 8, 16, and 32. Those are the first 5 terms that we've got in this sequence. So let's write those out. Our first 5 terms are going to be 2, 4, 8, 16, and 32. Now I'm sure you can see the pattern here. It looks like when we're doing this that this is just doubling each time. So to go from here to here, we go times 2. And to go from here to here, we go times 2. To go from here to here, we go times 2. And that pattern just keeps continuing. And so we'll say, okay, it doubles each time. And an easy way to show that is we can just divide any two terms. So for example, if I said T5, my fifth term, divided by the previous term T4, I'm going to get an answer of 2, because 32 divided by 16 is 2. Similarly, I could go T3 divided by T2, so dividing our two consecutive terms, and I end up with 2 as well. Okay, so that is an example of a sequence. But we're going to focus on this kind of sequence that you're going to see as our next one. This is going to be our focus for today. So we've got a general term of 3n minus 1. So let's do our first 5 terms. So our first term is going to be 3, and I'm going to put in a 1 wherever there was an n. So 3 times 1 is 3, minus 1 is 2. For my second term, I'm going to put in a 2 wherever there was an n. So 3 times 2 is 6, minus 1 is going to be 5. Same sort of thing for my third term. I'm going to end up with 3 times 3 minus 1. So that would be 9 minus 1 is 8. For my fourth term, it's going to be 11. And for my fifth term, it's going to be 14. Okay? So I did that just by subbing in where the n was. I would put in the numbers 1, 2, 3, 4, and 5 to get my first 5 terms. So let's write those out. We've got 2, 5, 8, 11, and 14. And so you got to ask yourself, what's the pattern here? What's changing each time? Well, I notice that each time it's going up by 3. We're adding 3 each time. So I'm going to write this underneath. Add 3 each time. Okay. I also notice that if I subtract any two successive terms, let's try my fifth term minus my fourth term. So I'm starting with the later term and I'm subtracting the one just before it. That's going to be 14 minus 11, that's 3. And if I take term 4 and I subtract the one before it, the fourth term minus the third term, that's 11 minus 8 is also 3. So I notice that by subtracting any two terms that are next to one another, the later one minus the one that just came before it, I'm getting this common difference each time. I'm getting 3 each time. Okay, I'd like you to try this. So here's this part of the video. I'm going to ask you to please pause your video right now. And I'm going to ask you to work through this. And when you're finished getting the first 5 terms for each sequence, I'll ask you to unpause the video and continue watching. So please pause your video right now. Okay, so I've shown some of the work you would have done there. I've subbed in for the first 3 terms. You would have had to do it for term number 4 and term number 5 as well. And then I've written out our 5 terms there. So hopefully you got those same answers. And now you found that you are able to take a general term and use that to generate any of the terms in our sequence. We could have put in, instead of 1, 2, 3, 4, and 5, we could have subbed in 1,000 or subbed in 1,063 or whatever to get that term in our list. So our general term makes it nice and easy for us to find any of the terms in our sequence. Okay, what we're going to do right now is we're going to try and find the general term rather than be given one. So we've got some patterns here, and we're going to try and figure out what's going to be the next number in our pattern and what is our general term. So here we go. I noticed for my first one, I seem to be increasing by 1 each time, so that's pretty easy. Going from one term to the next, each time I'm increasing by 1. So that means my next term is going to be a 5. For my general term, I'm going to start by writing Tn, of course, for my general term. And I notice that for my first term it's 1, for my second term it's 2, for my third term it's 3. So that means my general term is just going to be n. If I want my first term, I sub in a 1. If I want my second term, I sub in a 2. So whatever term number it is, that matches what that value is. So my general term is just an n. For the fifth term, I sub in a 5. Here's my next one. I notice that this one is going up by 5 each time. So that means my next number is going to be a 25. For my general term, I look at this and the first one is 5 and the second one is 10 and the third one is 15. It looks like whatever my term number is, I'm just multiplying it by 5. So my general term is going to be 5 times n. So if n is 3 for my third term right here, I would go 5 times 3 for my third term, and that would give me 15. So my general term is just 5 times n, 5 times the term number. Let's keep going. Have a look at this next one. I'd like you to tell me how much you see this one changing each time. If you said this one is going up by 3 each time, you're correct. So each time this one is increasing by 3. So you might be thinking to yourself, oh, okay, that's easy. I know the next term. The next term is going to be 16. And my general term is just going to be, because it goes up, when it was going up by 5 each time, my general term was 5n. So my general term must be 3n, because it's going up by 3 each time. But there's a catch. If we try and use that on our terms, let's say I'm going to get my third term here, right here. It's a 10. If I go 3 times 3, that gives me 9, not 10. So something's up. I notice that's actually my one just above, it started at 5 and then went up by 5. This one doesn't start at 3 and then go up by 3. It starts at 4. So because it doesn't start at 3, it actually starts at 4. I got to add 1 to that. And that'll fix my general term to make it correct. So my first term doesn't start at a 3, it actually starts at a 4. So I need to add 1. And my next term isn't just 3 times 2, it's 3 times 2, which would be 6 plus another 1. And then it's 3 times 3 plus 1. And then it's 3 times 4 plus 1. And then it's 3 times 5 plus 1. So I notice it's going up by 3 each time, but I'm also noticing it's not starting at 3. So I kind of need to use that plus 1 as an adjustment. 3n is how much it'll change each time. And the plus 1 is the adjustment for what my starting number is. Okay, here's the last one for this page. How is this one changing each time? Well, this one's not going up by a consistent amount, right? It's not we're not adding a consistent amount each time. So this is different than the other ones we've looked at. The other ones we looked at on this page are what we're focused on today. This is the kind that we're going to focus on tomorrow and in the coming days. So I see for this one, I've got 1 and then 4 and then 9 and 16. Here's my next term. It's going to be 25. And you might have guessed the pattern. I'm actually taking the term number 1, term number 2, term number 3, term number 4. I'm taking my term number and I'm squaring it. So my general term for this one is going to be the term number, 1, 2, 3, 4, 5, whatever it is, squared. So 1 squared gives me 1, 2 squared gives me 4, 3 squared gives me 9, 4 squared gives me 16. So this is a way that we can generate a general term. I am going to show you like a formulaic way to do that, but this is a way we can do it just by looking at our term. Okay, I want to talk about some different types of sequences. So here's our first one, and this is the kind we're focused on today. It's called an arithmetic sequence. So arithmetic just means we're adding or subtracting. Arithmetic sequence just means it's a sequence where we're adding or subtracting a common amount each time. So you add or subtract a common amount called a common difference for each new term. And the common difference we label with a D. D for common difference. So D for common difference. And that's an arithmetic sequence. That's what we're studying today. The next one is a geometric sequence. That's where you multiply or divide by a common amount to get each new term. So each new term you'd be multiplying by 5 each time, or dividing by 7 each time, or multiplying by -1/2 each time, or dividing by 0.32 each time. As long as we're multiplying or dividing by the same amount each time, that's geometric. And so we're looking for R, called our common ratio. Our common ratio is the amount that we're multiplying or dividing by each time to get a new term. We'll do that tomorrow. There's also a third category that's other. So there can be lots of different kinds of, because a sequence is just a ordered set of numbers. So sometimes you can't write an ordered set of numbers with a formula, with a general term. So for example, a list of prime numbers. Prime numbers are numbers that can only be divided by 1 and themselves. And there's no way to write a general term for prime numbers. We know what they are. We've well established them. But you can't write a general term where you say, oh, what's the 5,000th prime number? I'll just get my general term and I'll plug in a 5,000 everywhere there's an n. You can't do that. So some lists of numbers can't be written using a general term. Okay, let's talk formula. So our formula for our arithmetic sequences is going to look like this. On the left, you're going to see our Tn for our general term. That's kind of always what we start our formula with. And the n we've seen before as well. We know that's just our term number that we'll sub in. 1, 2, 3, 4, whatever, for whatever term we're trying to find in our list of numbers. And we've got the a and the d. So what are the a and the d? Well, we saw those on the previous slide. So our starting amount is going to be our value of a. So whatever number we're starting with, that's our first term in our series. Whatever our first term in our series is, that's what we're going to plug in there when we're trying to find our general term. So if our first term, term number 1 is -3, we put a -3 there. If our first term is 5, we'll put a 5 there. If our first term is a half, we'll put a half there. Whatever our first term, our starting amount is. And our common difference, that's the amount that is added or subtracted as we go from one term to the next. That's going to be our common difference at D, and that's what we'll sub in there. That could be a positive number. It could be a negative number, depending on whether our numbers are increasing or decreasing in our arithmetic sequence. You'll put in a positive or a negative number. That value of D is multiplying everything in the brackets. So we're actually going to have to multiply it by -1, and by n. We're going to have to multiply through the brackets eventually when we're looking to find our general term. This should go on your cheat sheet. So I'd like you to pause your video for a moment, and I'd like you to write this onto your cheat sheet for this unit right now, because this is one of the ones you'll need at your fingertips. Okay, you finished writing that down? Let's go through an example. We're going to try and find the general term and the 29th term for the sequence. 3, 6, 9, and 12. All right, so the first thing I need to do is I'm going to need to find my A and my D, my starting amount, my first term, and my common difference. So I notice it goes 3, 6, 9, 12. Looks like it's going up by 3 each time. So my starting amount, that's going to be A. My starting amount, that's my first term. I could also call it T1, right? Because that would be my first term. But my starting amount is going to be 3. So I'm starting at 3. Now, when I'm trying to find my common difference, I'm going to have to look at the difference between them. You could just look at it and say, oh, it's going up by 3 each time. But let's try and formalize that a little bit so that if we come up with a tougher one, we'll have a good method for it. So I got 4 terms there. I'm going to try and take the 4th term, and I'm going to subtract the one right before it, the 3rd term, and see what I get. So that's 12 minus 9. That's going to give me 3. And just to make sure it's consistent, I'm going to take the 3rd term, and I'll try subtracting the one before it, the 2nd term, and see what we get. So that would be 9 minus 6. That would also be 3. Now, I'm sure you could recognize that, but we're trying it on an easier one so that when we see a harder one, we'll have like a method for doing it. So it looks to me like my common difference, D, is going to be 3. So it just so happens that those are the same, right? My starting value is 3. My common difference is 3. It's just a coincidence that those two happen to be the same. Now we're going to try and find our general term. So let's use that formula that we saw above. We're going to say, all right, the general term is the starting value plus n minus 1 times our common difference D. So where there was an A, we're going to sub in our value for that. That's a 3. And where there's the D, our common difference, we'll sub in our common difference. That also happened to be 3. Of course, I got to multiply through the brackets here. We're used to seeing things we multiply through the brackets on the other side, like in front of those brackets. And so if you like that better, you could put it there, but the operation is the same. So let's write out what we're going to get from that. We've still got our 3 there. 3 times n is 3n, and 3 times negative 1 is going to be negative 3. Now let's simplify by collecting our like terms. We've got 2 regular numbers, plus 3 and minus 3. So let's collect those together. They work out to be 0, and we're just left with 3n. So that's going to be our general term. Now we said we wanted to find the 29th term. So all we need to do to find the 29th term is we need to take our general term, we'll sub in a 29, and we'll see what we get. So that's going to be 3 times 29 for the 29th term. We put in the 29 where there was the n, and so that's going to be 87. So I can say, therefore, the 29th term is 87. Okay, now I'd like you, hold on. All right, let's do one more together, and then I'm going to have you try one. I'm going to move a little bit faster through this. So I'm going to do basically the same thing I just did, but kind of in a quicker fashion. And this one I notice is decreasing. 32, 30, 28. I notice it's going down. So find my general term for this sequence. So again, I'm going to follow my method. I'm going to say the third term minus the second term. Let's see what that's going to be. That's going to be 28 minus 30, and that's going to give me negative 2, which makes sense because it's going down by 2 each time. What if I take my second term and I subtract my first term? That's 30 minus 32. That's also negative 2, which makes sense, right? Because I can look at my pattern and I can see it's going down by 2 each time. So with that, I can say my common difference is going to be negative 2. Cool. Do I have a starting value? Yes, I sure do. It's 32. So now that I have those two, I can plug them into my formula to try and find a general term. So my general term is going to be my starting value plus n minus 1 times my common difference. My starting value is 32. My common difference is negative 2. So careful here. I'm going to put negative 2 in brackets. And I'm going to remember that I'm working with a negative number here. That's important to make sure that my algebra is going to work out correctly. So let's multiply through the brackets. What will we end up with? Negative 2 times n. Oh, I shouldn't have put a plus there, because that's actually going to be a negative number. A negative times a positive is going to give us a negative, of course. So I'm going to go minus 2 times n. And then I've got negative 2 times negative 1. Negative times a negative gives us a positive. So that's going to be plus 2. Let's collect our like terms. 32 plus 2 is going to be 34 minus 2 times n. So what this says to me is I have 34 in the bank, but for each term number I'm taking 2 away. For the first term I'm taking 2 away. For the second term I'm taking 2 plus 2 away. For the third I'm taking 2 plus 2 plus 2 away. Now we could write it like this. You could also have written it with the n value first, but you'd have to watch your signs, right? So if you wrote it like this, negative 2n plus 34, that's the same thing. So that's also correct if you were to want to do it like that. Now to get any particular number that you want, say you wanted to get the 1000th term, you just plug 1000 in where the n is and then solve for that, and that would be your 1000th term. Okay, I'm going to ask you to try this now. So let's check your understanding. For this sequence, I'd like you to figure out what's the general term. Go for it. Pause your video now and give it a try. Okay, so you've figured out this one, and I'll just post it, the general term here for you. So our general term for this one is going to be 30 minus 5n. Okay, so hopefully you were able to get there. Now we're going to try a little variation on this. We're going to try and figure out not what is our general formula necessarily. We might need that. But we want to figure out how many terms are in this sequence. It starts at -3, and then the pattern continues all the way up to 152 and then stops. So we've got our dots in between, and that tells us there's some numbers in between there, but we don't know how many. You might see in one of the Kahoots we're going to do today, say I had a pattern where there was 5, and then underline, underline, and then that. Right? You would have to guess, oh, that's a 10 and that's a 15 to make that pattern continue. So you might see things like that. But in this case, we're just looking at, there's the like dot, dot, dot. What does that mean? So the dot, dot, dot just means that there's some indeterminate amount of numbers in between there. We've got to figure out what they are. Okay? So I can just look at it and I can see, it looks like it's going up by 5 each time because it's starting at -3 and then it goes up to 2 and then up to 7. Looks like it's increasing by 5 each time. But let's kind of be careful. Let's do this the right way. So I'm going to say my third term minus my second term, that's going to be 7 minus 2, and that's 5. And my second term minus my first term, that's going to be 2 minus -3, and subtracting a negative is like adding, so that's also going to be 5. So it looks like my common difference is going up by 5 each time, and my starting value is going to be -3. So let's plug those in and get a general term. So we'll say, okay, Tn equals, I'm going to put in first the -3, that's my starting amount, and then I've got my n minus 1, and I'm multiplying that by +5. So +5 times n is 5n, +5 times -1 is -5. Let's collect my like terms. Now I kind of would like to have the 5n first, just because it's kind of nicer to have a positive term first, and then I'm going to have -8. So this is my general term, 5n minus 8. Now what I want to do is I need to be able to figure out how many terms are in here. So here's what I can do. I can plug in one of my terms for here, and then I can solve for my n value. I can use algebra to solve for n and see what I get. So let's do that. Let's plug in our term number of 152. That's the term where I end up. That's my last term. So if I can figure out what n is, that'll tell me what number of term it is. It's not first, it's not second, it's not third, it's something after that. What am I going to get? So we got to solve for n. So first thing I'll do is I'll add 8 to both sides to get rid of this -8. So on this side I'm just going to have 5n, and on this side I got 160. Then I'm going to divide both sides by 5. I'll get rid of those. And I'm just going to end up with an n on this side, and 160 divided by 5 is 32. So that tells me the term number 32 is 152. The 32nd term is the 152. So let's do a cute little therefore statement just so I'm showing I'm understanding. I'll say therefore there are 32 terms in this sequence. Cool. Okay, now I'm going to want you to try the exact same thing. with a different set of numbers. Okay, so here you go. I'm going to ask you to pause the video here. And I'm going to ask you to try and figure out if we have a sequence that starts with 3, goes 10, 17, and then goes all the way up to 311 and stops, how many terms are in this sequence? Go for it. Pause your video now. Okay, there we can see our answer. Hopefully you got there yourself, that there are 45 terms in this sequence. I really don't want you doing the thing where you're just counting up, counting by sevens, and saying, oh, okay, 17 plus 7, that's 23, plus another 7. Like, don't, 24, rather. Don't do that thing where you're counting up by sevens and just seeing how many times. Actually do the math, because we need to be able to do this method to solve more complex ones. Okay? So that's it. That's all I wanted to take you through for today. Now it's time for your tasks for today. Everything is on Edsby. You've got 2 Kahoots that are linked there to complete at your own pace. And then some book stuff. A reminder that for this chapter, we're all using the same textbook. I posted the particular chapter on the agenda for Edsby today. One thing I want you to watch out for is ignore references to recursive formula. You don't have to do any of the stuff where it says recursive formula. Just ignore that because we're going to cover that later. Good luck. Work hard. Work smart. And I'm looking forward to seeing you tomorrow. Bye for now, folks.